Right now, a fundamental secret is hiding in plain sight, tucked away somewhere deep inside our very own solar system. In our immediate neighborhood, the laws of physics are perfectly predictable. Look at Jupiter and its moons. They behave exactly as the math dictates. Every planet traces an exact mathematical orbit, moving through space without a single unexplained deviation. This precision comes from Einstein's playbook. His theory of general relativity provides the rules for how mass bends spacetime, and nearby, every object follows those rules to the letter. We have confirmed this for decades. Every probe sent outward behaves as if standard gravity is the only force at work. Locally, standard gravity remains the absolute, undisputed rule. But on a massive scale, the universe seems to stop following that playbook entirely. Observations of distant galaxies reveal they are being pushed apart much faster than the known laws of gravity allow. To explain this acceleration, scientists use the term dark energy, a placeholder for a phenomenon they don't yet understand. This creates the Great Disconnect. On one hand, we see gravity pulling things together locally, while on the other, an unknown force pushes the universe apart globally. This creates a problem. The fundamental rules of the universe shouldn't change just because we are looking at things from further away. Why does the universe follow two different sets of rules depending on where you look? The prime suspect is an undiscovered fifth force of nature that operates in the deep reaches of space. If this mysterious force is truly powerful enough to move entire galaxies across the universe, it should be easy to find. So why haven't our local probes ever felt it? Researchers believe this force uses a mechanism called screening to hide from us, changing its behavior based on its environment. One leading idea is the chameleon model. In this scenario, the force adjusts its strength based on how much matter is nearby. In the low-density void between galaxies, this force becomes strong, creating the pressure that drives the universe's expansion. But inside our solar system, the high density of matter forces the chameleon waves to weaken and shrink, making them nearly impossible for current instruments to detect. The sheer density of our planetary neighborhood effectively crushes the fifth force into hiding. A second possibility is the Einstein screening model. Massive gravitational fields actively overpower and suppress the fifth force, masking its presence without physically weakening the force itself. Here in our own local neighborhood, the primary source of this suppressing gravity is the sun. Mathematicians call the edge of this suppression zone the Einstein radius. Inside this boundary, the sun's gravity is so dominant that the fifth force becomes invisible. For our sun, this radius extends roughly 400 light-years. That means we, and thousands of our neighboring stars, are currently trapped inside a massive gravitational blind spot. Humanity is living in a zone where the fifth force is effectively shielded from our view. Staring out at the distant universe through telescopes only shows us the effects of the force far away. It won't help us find it here. Slava Turyshev, a physicist at NASA's Jet Propulsion Laboratory, is calling for a different strategy. He argues that simply repeating standard tests of general relativity won't yield new results. Instead, scientists must use deep space data to create hyper-precise, testable predictions that are tailored to the environment of our solar system. To find this ghost, researchers need a targeted search right here in our own neighborhood. The first step is developing a dedicated mission with instruments sensitive enough to detect the subtle traces left by screening models. This would require a massive engineering effort and a planetary mission unlike anything we have attempted before. Success depends on having a theory that is actually falsifiable before the countdown even begins. If a future probe catches this force in action, it won't just bridge the Great Disconnect. It will provide a new, unified understanding of how gravity and the entire universe actually work.